Okay, let's start talking about what is a monochrometer. If you remember, the whole thing about UV-vis instruments are you have to have a source that's going to produce wavelengths, and you're going to have some sample and some detector. But the detector has to be able to select a wavelength. So the whole purpose of a monochrometer is being able to select what wavelength you're actually studying. The selection of a wavelength is the action of the monochrometer. Now, the term monochrometer literally means, one color, but the problem with that is that no monochrometer actually selects a single wavelength. What a monochrometer does is select a delta wavelength, the bandwidth. It's the best it can do. The smaller the bandwidth, equals better resolution. So, the way that we're going to select a bandwidth in a monochrometer is really pretty simple. It starts with the whole concept of, a prism as a dispersive method of selecting wavelengths. So if we have our three wavelengths here, and at this point it would look white, but if we run it through a prism, what's going to happen is our wavelengths are going to get spread out or dispersed over a certain range. We'll call that delta x. And that's going to be the dispersion. So the better the dispersion, the bigger the delta x, the more the light is spread out. In order to select a wavelength, what you do is you put a slit, a mechanical object in the way, that only lets a narrow range of that light slip through. So we'll call that slit width W. And the narrower you make the slit width, the smaller the delta lambda that gets through.